Hi guys, thanks for tuning in to another video on ForgottenWeapons.com. I'm Ian McCollum, and today we are here talking to Tony Neophytou, who is the designer of a couple of fairly iconic, if not massively production successful yet, South African firearms designs. So he has made it very easy to tell which guns are his by starting all of their names with Neo. So the Neostead 2000 shotgun, the NeoPup 20mm personal assault weapon, grenade launcher. It's an interesting hybrid system. And the NeoStrike machine gun, which is still a work in progress. And then the NTW-20, which doesn't actually have the name Neo in it anywhere.
Correct.
So what I wanted to talk to you about is, like, what's the reality of firearms design? Because there are very few people out there who have actually gone through the whole process of, let's come up with an idea, let's get it designed on paper, build a prototype, evolve the prototype through to a working production gun, and then actually make it. And not just once, but 3 going on 4 times now for you.
Sure.
So most people don't have any idea what's involved in that.
There's a lot more involved than people think.
Right.
It will end up taking you a lot longer than you think.
No kidding.
The difference between a concept and a working something is huge.
Yeah.
And the problem with a lot of guys like me is they end up falling in love with their concepts.
Okay.
And that's the first mistake you make. You have to be your own harshest critic. And the sooner you learn that, the better off you are.
Okay.
Yeah. And it's just a matter of buckling down and starting the work, making drawings, sketches. If you can have someone help you on a computer to render all the drawings, the right dimensions and so on, is extremely important and very useful. And in fact, nowadays in this modern world, unless you can do that, you're going to really struggle.
Yeah.
Yeah.
Now, the first issue, if you're going to design a gun, is what are you building? And there's a big, if you look at your designs, they're all very unique, and they're all done specifically to address discrete purposes. They're not, you've never done a gun, at least not one that I've seen, that is, I'm going to make a 5.56 rifle to replace the R4.
I ask myself, if you design a new weapon, is it going to do anything different to the enemy? Question number 1. Question number 2, if there are so many other similar guns out there that are extremely well developed, that have gone through years of refinement and so on, you have to ask yourself, what are you going to do that's a little better? A tiny incremental change, does it justify you spending so much time and money, and then you've got to convince a user that your safety is better than the other safety? Does it really count? It's not worth the time and energy. So I made it a big issue for myself to try and design something which is different enough that warrants the effort and energy to make it. Is different enough for the user that it gives him some added capability, some new capability. And unless you can do that, I don't see the point of actually doing it. Yeah.
And you're also implying here that the gun that you design is really not the same gun that may exist in 20 years if someone's actually using it.
Absolutely.
If you want something to be better than what's on the market, you don't just have to make something that's better, let's say the M16. Your design has to be better than the M16 now.
Yeah, absolutely.
Not just better than the M16 when it first came off the drawing board.
You've heard the old saying, the last of the old is always better than the first of the new.
Right.
So anybody who wants to be the first of the new, good luck to you. That's the zone I've chosen to be in. And it's actually a very tricky zone because you put yourself out there. And whatever you do, you have to hope that you're doing the right thing, that people will accept and understand what you're actually trying to do. I think a perfect example is you having fired PAW. Having not fired it, it's an oddball thing. You think, what's this layout for and how come, why, where? The moment you fired it, the moment you experience it, then you see flash.
Yeah. And boy, I tell you what, just today, and we've been here in South Africa traveling around and filming for almost a week now. And it was just this morning that the thought popped into my head of the PAW as an anti-piracy weapon.
Absolutely.
You get, we're all familiar with the issue with like Somali pirates and cargo and oil vessels, and how do you defend against that? Yeah. And what guys are doing is like they're getting Barretts or water cannons when they're not allowed to actually have firearms. But man, you give a guy on the deck of a ship like that a PAW, And there's some little rinky-dink speedboat full of Somali pirates that's one shot, and they're going to have an extremely bad day.
For example, on PAW, I look at everybody trying to make guns more accurate. I think, to what end?
Well, that's so that you can better hit the enemy.
With a more accurate gun.
Right.
What I'm trying to do is give you a gun where you don't have to be more accurate, where a near miss is actually still fulfills the same purpose. So it's just a different way of looking at things.
Right. If you have a 2-meter lethal bursting radius on an HE shell,
exactly. Yeah.
Well, okay, instead of being half a minute more accurate with a rifle,
yeah.
you can miss by a meter.
Yeah.
And that still counts as a hit.
I often look at a machine gun. This is this mechanism that is battering itself to death at 700,000-800,000 shots per minute to deliver all these tiny little bullets into a target zone to deliver some kind of effect. Whereas in the case of what I'm doing with PAW, you're firing one projectile and the effect is done on the target. It's built into the ammunition, not the weapon.
Right. I suppose we actually should mention PAW is personal assault weapon, and PMP, or Denel, I'm still trying to get...
Denel is the big organization, and PMP is a division of Denel.
Okay.
And the NeoPup has now been called the Inkunzi PAW.
Right. So when you first designed it, you called it the NeoPup.
Correct.
And that's Neo for your name, and Pup is in bullpup.
Yeah.
Because it is mostly a bullpup system.
But that is why I called it the NeoPup, because it's neither a bullpup nor a conventional gun. So I just thought it was very convenient to be able to coin a new term for a gun of this layout as a NeoPup. Yeah.
And then when they bought it, PMP renamed it the Inkunzi, which is Zulu or
bull.
For bull.
Zulu for bull.
Yeah. Yeah, that's a cool name.
Yeah.
And it's a descriptive name, too.
Yeah, absolutely. Yeah.
So one of the things that was interesting, we took a look at your shotgun, and you have a very low opinion of your own shotgun.
Yeah.
Why?
I've discovered that the gun world does not like revolutionary stuff. The gun world tolerates evolutionary stuff. And the shotgun is a perfect example where every single detail of that gun is not like any other shotgun. So already you're exposing yourself to risk of not using proven ways of doing things. There's the added complexity of what the gun is, the selectability of the tubes and all that kind of stuff. So it's not the right route to go. There's just way too many things that have not been proven. So it's not an incremental improvement. Whereas I look at PAW on the other hand, every element in that gun is actually easily recognizable, as you see. There's one revolutionary element in that gun, and that is the position of the pistol grip.
Right.
And even with that one revolutionary element, it still takes convincing.
Right. A lot of convincing.
And you've understood and seen why it is that way.
Yeah.
And
it makes sense.
Had you tried to design that gun as a bullpup or as a conventional rifle, you would have introduced other disadvantages in it.
Right. Yeah. I think beyond its acceptability in the marketplace, this idea of using proven, simple systems is extremely important to actually make a gun work. Because there's a huge difference between make one prototype by hand and fit and file it and get it just right, and those things almost, as long as they're done right, those always work great. The problem then comes when you try and transition from that to let's make a production line and build 50 of them. And then it transitions again when you go, let's build 1,000.
Absolutely.
And I thought the NeoPup was really cool. And the shooting I did was with your very second prototype.
Yeah.
And sure enough, it worked almost flawlessly.
Yeah, absolutely.
But then we took it apart. And you start looking at every system of the gun, the loading assembly, the trigger assembly, the ejection, the feeding, every part of that has a whole lot of weird, complex, small parts going on. And I can immediately, it was actually very interesting to see that, one of your first designs compared to the PAW, and just a huge difference in, I think, experience.
Absolutely.
Yeah.
The one thing about the PAW, which makes life as a designer even worse, you're trying to design a new round of ammunition and the weapon for it.
So that cartridge is yours as well.
Absolutely. All the original work was done by me. So it doesn't compare to any other cartridge. Its characteristics, the way it handles in the magazine, ballistically, the recoil, its ratios of projectile weight to propellant mass and so on, is completely different. So this is a learning curve on its own.
For people who have no idea what it is, maybe they've seen pictures of the
Yeah.
PAW, what is the cartridge? And what's the what is it and why is it that way?
It's essentially a 20mm projectile. 20mm, as understood by most people, as an anti-aircraft gun of some sort, or an aircraft gun of some sort. Those guns normally fall into the weight bracket of a 40, 50, 60, 70 kilogram weapon system, part of a turret or an aircraft or such like.
Yeah.
I had some experience with those kind of weapons, and I loved the 20mm projectile and how it performed. And I always thought it would be very nice to have a little handheld something that could deliver the same payload.
And when you're saying perform, you're talking about high explosive.
High explosive,
right.
Absolutely. And the big difference with this, compared to existing grenade launcher type weapons, they have very low velocities. They have very high arcing trajectories. So they're always supplementary weapons to a rifle. Rarely are dedicated as a grenade launcher only. What I attempted to do was create a grenade launcher that shoots like a rifle.
Okay. So looking at this cartridge, it's about this long.
Yeah.
And what's unusual about it is it's about 2/3 projectile and 1/3 case.
Correct.
So the case itself is 20 by 42, I believe.
Correct. Yeah.
That case is shorter than a 7.62 NATO.
Yeah.
At 51 millimeters.
Yeah.
But you've got this ginormous explosive 20 millimeter projectile on the front. And so like you said, that introduces this, it's is it relatively low pressure? I guess it probably isn't low pressure.
It's the same pressure ballpark as a 303.
Okay.
So it's not low pressure in the same sense as a 40 mil by any stretch.
Right.
And neither is it a high intensity like 5.56 or 338 or that kind of cartridge.
I guess what you get with that is you don't really have much in the way of flash and...
Not at all.
Like, would you put a muzzle brake on it?
Absolutely not. It would be absolutely futile. I've made a few of them, tried to measure them. You could barely register any recoil reduction. That kind of cartridge where you have a huge payload projectile and a small powder charge is not what works with a muzzle brake. A muzzle brake needs the opposite, a small projectile and a big powder charge. Muzzle brakes work on propellant gas, and you need big volume of it to make it work.
Right. The other unexpected thing for me shooting the PAW was how you try and handle the recoil. Because that thing kicks. And in fact, you said, because it's your cartridge, you experimented a lot with muzzle velocities.
Yeah, absolutely.
From too low to too high.
Yeah.
And actually, first of all, what did you end up with and why did you pick that?
At the end of the day, I can reduce the velocity and reduce the weight of the weapon. The velocity then starts approaching that of the 40 mil systems.
Okay.
So for a user, what would be the advantage? You wouldn't gain the advantage of a flat trajectory and high velocity.
So what is the velocity of a 40 millimeter?
40 mil standard low velocity is about 76 meters per second. The new improved versions can go up to 120.
Okay.
They call them extended range 40 mils. But still, they're extremely slow, and the arcing trajectory is extremely high.
Okay.
Yeah. To give you an idea, the standard one, 300 meters, has a 26 meter high arc.
Wow.
40 mil.
That's like 90 feet.
Correct. Whereas the 20 mil PAW is 1.4 meters.
Okay.
So you can see the huge difference between the two.
That is much closer to a rifle sort of trajectory.
The time of flight to 300 meters on the 40 mil is almost 5 seconds. Whereas the PAW is just over 1 second.
Okay. And the velocity that you ended up using?
It was 310 meters per second.
Okay.
Yeah.
And you said you experimented with up to like over 400.
Correct. Yeah.
And I already know the answer to this, but why not 400? Then it'd be even flatter and faster.
You'd have to increase the weight of the gun or increase its length to increase the recoil stroke. And at what point do you call it a day in terms of it's now become too heavy or it's too long and it becomes impractical and won't be accepted by the user? I think with the combination of this velocity and this weight, which you understand, it's not the lightest of guns.
No, it really isn't.
But I ask you the question, how much do you think I could reduce the weight of the weapon?
You did, and I don't think I would reduce it.
Or would you live with a reduction in velocity for a reduction in weight? That's the call that I made.
It almost sounds like you're implying that everything in gun design is a series of compromises.
Absolutely, 110%, big time. The other thing is I did have in mind a progression of this design into a machine gun.
Okay.
To make the entire project more worthwhile. so there was a machine gun in sight. I didn't want to sit with the same situation as the low velocity 40 mil and the high velocity 40 mils. They're both 40 mils, but there's a lot of confusion between the two. I wanted to have commonality between the belt-fed version and the handheld version.
Okay.
That if you have a couple of troops in a vehicle armed with the PAW, and there was a 20 mil machine gun type weapon on the vehicle, the ammunition is usable by both.
That certainly makes sense. Yeah, and if you sacrifice velocity, you're going to be hurting the machine gun practical nature more than the PAWs.
Yeah. I would like for the machine gun's sake to have kept the high velocity.
Yeah.
But I would have ended up with two different cartridges.
Right. Which has its own downside.
Yeah.
So speaking of that, what I was initially going to get to was, how do you handle the recoil of this thing? Because it kicks. This is not... one of my friends saw something about it, and her comment was it recoil was harsh but manageable, which is like the classic gun magazine thing. That's code for this kicked the shit out of me.
Yeah, absolutely.
Well, the PAW absolutely recoils.
Yeah.
And when the first time I went to shoot it, I figured, okay, I've done recoiling guns with a lot of recoil, machine guns. And the key is you're aggressive and you lean in and you control the gun and keep the muzzle on target. And that didn't really work. And what you told me, you watched me do that and not handle it all that well.
Yeah.
And what you said was, no, let it rise. Just ride the recoil up.
Yeah.
And it occurred to me that with a grenade launcher like this, you don't have to keep the muzzle on target because there isn't a second round immediately following the first one. And while it isn't a 40 millimeter, it's also not quite a rifle bullet. And so you've got a discrete period of time.
Absolutely.
And you fire, and as it's recoiling, you observe the impact, see what happens, determine if you need to fire again or where you're going to fire.
Yeah.
And by the time you come down onto target, you're fine. You don't have to try and, IPSC speed drill this thing.
Not at all. I've discovered recoil depends on recoil motion, distance. You could effectively fire an artillery shell if you had a rail that was half a kilometer long. You would feel no recoil.
Right.
That's an extreme, stupid example.
Mm-hmm.
In this case, the receiver of the gun recoils into the buttstock. And if you look carefully, the buttstock, pistol grip, sight assembly is independent of the recoiling portion of the gun.
Right.
What I'm trying to do is isolate as much as of the body from the recoiling mass as possible.
Yeah, it's somewhat, the closest thing I think would be an FG42.
Correct, but that's
which
very,
has
very
a lot,
short.
Yeah, has a lot less of that effect.
Yeah. This is almost 3 inches that
Yeah.
you're allowing the gun to go back. So that gives the recoil not time to disappear, but to spread over a longer time. So if you had a graph, it wouldn't be the sharp peak, which is what hurts,
Right.
or a shotgun with a big load, light shotgun. In this case, you flatten that peak out dramatically and spread that recoil load over a much longer period of time.
Okay. So if you were if someone came to you and they're like, I'm going to design a gun, and I've got this great idea.
I would tell them to sit down until the feeling goes away. Really, I think unless you really have a passion and you really are going to muscle it through and you are really going to discover all your mistakes and really do something about it, you cannot believe the smallest thing is sometimes extremely difficult to understand and get to work. It really will give you a much better understanding of existing guns, not taking them for granted, ordinary guns, because it's a huge task. It truly is. And even getting it made, getting the springs, getting the right materials, getting the heat treatments. We're talking about things that are one-offs. So ordinarily, where you had 1,000 of something to heat treat and you pay a minimum charge. Imagine going to someone and saying, I want one little pin hardened, and you're going to pay $100 for it.
Yeah.
And you're going to wait 3 weeks to get it back. These are the difficulties that you encounter as you go along. It becomes difficult.
Okay. Now, let's say for argument's sake, I'm just going to keep pestering you about this. I'm not going to give it up.
Yeah.
I'm going to design this gun.
Yeah.
Where would you start?
I would start by having a very good knowledge of existing guns that might be similar in some way, for you to go and examine them and ask detailed questions about the guns. Not a general, it's a 2-light bolt. Oh, I'll do that. You really need to understand, why is it a 2-light bolt? and not a 3-lug or a 4-lug? And what is the difference between a 2 and a 4-lug? And how would it impact the design that I want to do? And it becomes a real difficult toss-up about which of these are you going to choose. You choose this one, you lose on that. You choose this one, you lose on this. So at the end of the day, it's going to be a compromise either way. And you end up painting yourself in a corner.
Okay.
Because at some point you've now committed too far. And at some point it becomes very difficult to scrap your idea. That's what I meant earlier on. You've got to be your harshest critic. You can't wait for the user to tell you your gun ain't going to work.
Yeah, because it won't get that far.
It won't get that far.
I have to throw in, because this is just too perfect of an example of what you just said. The Lebel and the Berthier, the bolts are virtually identical. They fire the exact same cartridge. One, and they're both 2-lug bolts. One of them is this way, and one of them is this way.
Yeah. Why?
If you don't know why, you don't know enough to be...
Exactly.
You're not Berthier or Colonel Lebel, and you're not ready to design the gun.
You're not ready to design a gun. That's what I mean. You've got to have a sense of past, a sense of... A lot of things have been done before. We saw the Becker shotgun recently. It predates a lot of other guns that tried similar things.
Yeah.
It came many years later.
It's a blow-forward, rotating, cylinder-fed semi-auto shotgun.
Yeah. In essence, that's it. It takes a lot of passion, a lot of dedication, a lot of work. And unless you're really prepared to do that, and obviously the ideal thing is if you had somebody who was willing to pay for a lot of this stuff, it ends up costing you lots. Because I can tell you, you will fill a skip bin full of parts that don't work before you get there. I have filled many, believe me.
I absolutely believe that. Yes, I've talked to some other people in the same situation who have metric tons of scrap parts.
Take a magazine, for example.
That's the easiest part of the gun. It's so simple.
But in the circles, it's acknowledged that magazine is an extremely difficult thing to make work. So again, can you find a magazine off the shelf that could work with your gun? It's already solved 20% of your problem.
If not more.
Exactly, if not more. Absolutely.
You had magazine problems with the PAW.
Absolutely.
Yeah.
Absolutely. I started with box magazines. I tried everything in the book and truly never worked at all. I ended up using a rotary magazine, ended up being successful. It controls the cartridges very nicely. I have no problem with it at all. I could go into the details why the box magazines don't work.
Yeah.
But what a perfect example is there with the new cartridge. You can't go and look at ordinary magazine and expect what goes on there to apply to this cartridge.
Okay.
There's different things happening there because of the masses, the way they align the magazine, the ratio of length to diameter is different to a normal cartridge. So it's a different thing completely.
And you've got a belted case too,
which
introduces kind of some of the problems of a rimmed case, but not quite in the same way.
Not quite in the same way, but.
So you could go out there and look at all of the existing box magazines for large belted cartridges, of which there aren't.
Sure. You might ask, why don't you look at a Saiga 12-gauge shotgun magazine and apply it to a 20mm?
Yeah.
A 12-gauge shotgun is a puny thing compared to this 20mm cartridge. Its mass distribution is completely different to a 20mm cartridge. They've solved the problem of dealing with a rimmed cartridge in the shotgun and a flat nose. But you cannot apply the same things to this cartridge.
Another one of the cool iterations, little weird problem that comes up that you told me about was the magazine catch on the PAW.
Absolutely. Initially it was at a nice 45-degree angle, which ergonomically was the natural place to put it. You go out and shoot and shoot and shoot, and every now and then the magazine would fall onto your toes. Now,
by the way, it's a heavy mag.
It's a heavy magazine. When it falls on your toes, you will know it. And you don't know why it fell. Is it the hardness? Is it where it interfaces? What is it? What is it? It's only after a long time when you're fortunate enough to get access to high-speed video that it becomes obvious. The recoil, because the catch is at a 45-degree angle, would just rotate it flat into the released condition. And that would allow the magazine to fall out. Which is why if you look at all the new catches, they're all exactly in the direction where it can't rotate under recoil.
Right, and you have to push it down.
And you've got to push it down.
Yeah.
It's easy enough to use.
It is, actually.
But there's a reason why it is like that.
Right. And the natural, the reason that you started vertical is exactly what you would expect. Yeah. That's the most comfortable way to do it.
Yeah.
But then here's this weird problem that you can't find hardly anywhere else.
You take a famous guy like Mauser,
Mhm.
and everybody looks at his Mauser 98, the epitome of a bolt-action military rifle.
Mhm.
Everything on that action has a purpose and a reason. Every little bump, most people don't ask about. He didn't design it in 2 weeks.
Not
He
quite.
started in the 70s. He went through the crudest single-shot gun, and if you look at all the Mausers that developed from the 70s to 1900, there were many, many variations. He learned
Mhm.
from all of those, and it eventually evolved. That's why I say the first of the new was terrible,
Uh-huh.
and the last of the old, which is 98 effectively, was brilliant.
Right.
So if you think you're going to have your gun refined and ready for military market use in a year, it's not going to happen. Even big companies now will test and test. Real companies who really want to be in the game.
And if you don't have, a big company can afford to do that. They can take 10 years to develop a product.
Absolutely.
If you're an independent designer, you have to make something that's good enough in its like first or second iteration
Early on.
to attract a client to actually put money into the system.
Absolutely. Yeah.
Because the other thing is, I don't know that it's even possible for an independent designer to be able to do that effective sort of testing. A lot of that is you have to have a production line, you have to make 50, and then start debugging your manufacturing processes.
Absolutely. Absolutely.
You can refine a handmade prototype all you want, and that doesn't really solve the same problem.
But at the same time, every new idea has to start somewhere.
Right.
And usually a good new idea isn't a committee idea. It takes an individual. If you look throughout history with weapons, it's always some crank, some guy out in the sticks. Look at the percussion system with, what's his name?
Paul?
Forsyth.
Yeah, Forsyth first.
He was a vicar who did bird hunting in bad weather, and he developed and refined the percussion system. Look how many iterations that went through.
Maxim's another good example.
I was telling you the other night, mentioning that it took the British Army, I think, over 35 years to adopt a percussion system from Flint.
Yeah.
There's a perfect example of how long it takes to get these things embedded, accepted, proven.
Yeah.
Sure.
No, that was a pretty revolutionary change.
Sure.
But Maxim's the same way. Look at the very first Maxim gun.
Absolutely.
That thing is awkward and clunky as all get out.
Yeah. The difference between the shotgun and PAW. Same thing. If you look at his first gun, the little thing moving around in a shape, I was just, what was he thinking?
Right.
But nobody else had done it.
Right.
Somebody had to start. And
no, there isn't any military out there that put out an RFP for, we would like a gun with a 250 round belt that will fire automatically.
Absolutely. Yeah.
And yet you see that with the machine gun in general. It took a long time to convince the military that this new weapon actually had an application. Yeah. I think you see that with the light machine gun. Yeah. And that's why going into World War I, there were light machine guns out there. Yeah. Guns like the Madsen, but nobody really understood how to use them.
Absolutely.
Huge potential, not realized until after you force people to engage in the biggest world war to history at that point.
Or the guns get deployed incorrectly. Somebody kind of managed to get it in, and then it takes some creative young lieutenant who gets caught in some situation, and he ends up using the gun in a way which he was never told to, and it transforms everything.
Yeah. The mitrailleuse, the multi-barreled proto-machine gun that got one use in the Franco-Prussian War, and they tried to use it as artillery, which it was totally unsuitable for. And as a result, that thing, basically, that was the death knell of that whole system.
But that was stopped.
Right.
Other people came after. They saw, well, hang on, but if we do this and this, and there was a Maxim, and there was... So it continued. Am I on the right path with my stuff? I don't know. Time will tell.
I hope so.
I just hope that I've created something new and useful to a user. That's all.
The one other cool thing, I was trying to lead you into this earlier. The most important, like where you start with the design process. You've got the concept, you've got the basic, like, okay, this is how it's going to lock, this is what it's supposed to do. And then you said the first parts you would design are the springs, which I think is totally not something that most people would think about.
Absolutely. I've dealt with many people who've been involved in gun design, and they've asked me advice and all this kind of stuff. And I've seen people try to make bits of new gun, and I'm absolutely surprised. They always think, well, we'll put the springs in afterwards. I've thought of the concept. As I said earlier, the concept is easy. It's an execution of the concept. A practical execution, that's the real difficulty. I think a lot of people can think a lot of new concepts up. It means nothing. And the guys will come to you and then suddenly you realize there's not enough room for the spring in diameter or length or whatever it is. I say the springs are the soul of the gun. Without the springs, it's like a dead body. It's not alive. So really, when I say put the springs on first, I mean put them in early and make sure that there's provision for enough room to contain the springs and where they go and where they fit and how they work. Do they have enough energy? Do you not run out and have to make weird springs now to get the thing to work and all that kind of stuff? Vital, absolutely vital.
Yeah. Yeah, it's that nothing can really kill a design more than just a little bit too weak of a spring.
Yeah.
You know, it's going to recoil harder, it's harder to shoot, it's going to batter the gun internally.
You've seen cocking some guns is more difficult than others.
Yeah.
And so it carries on. So, and as I say, it's just dedication. It's dedication. You have to look and work and look and work and try and feel and try and feel. I'll make one spring that's wrong. I'll make another spring that's wrong. I'll make a component and it doesn't react and behave. I think in Ludwig Olsen's book on Mausers, there's an excellent chapter in the, or a little verse somewhere in the beginning of the book where he explains that it takes years and years to make parts which eventually look obvious.
Right.
And their function looks obvious.
Yeah.
And that's exactly the truth of it.
Yeah. I think Kalashnikov is quoted as saying something like that.
Yeah, sure.
It's now I can't think of it. It's easy to make something complex. It's very difficult to make something simple.
Absolutely. Talking about that, I look at a lot of earlier gun designs. I think it was Steyr-Hahn, right, with a stripper clip, a rotating barrel. How many components has that gun got?
That's an interesting question, but not a whole lot.
I think it's something ridiculous, like 22 or 26.
Yeah. Yeah, outside of the fire control group, the action is very simple.
Now, if you look at a modern handgun, how many parts have they got?
Often more than that.
100, 120, 130. Look, they have a bit of functionality, a loose magazine and so on. But imagine asking you to design a gun with 25 components.
Now there's an engineering challenge.
That is an engineering challenge.
Ooh. Yeah.
Sure, they did things differently. For example, the safety catch on that particular pistol detents itself and it keeps itself assembled to the gun. Do you understand what I mean? So you didn't just make one component and expect a ball and a spring to keep it in and a separate pin to keep it. He designs one component. It makes it more complex and expensive. So that's the downside of that.
Right. But that sort of thing tends to be more reliable. It's easier to field strip. I think that's something that's maybe underestimated, maybe not, but it's certainly a very good, I think, measurement of the quality of a design.
Yeah.
It's how hard is it to take apart?
Now, please, you look at PAW, no loose pins.
Yeah. Yep.
I know a lot of other guns have loose pin and a little hole in the stock or some way to sort it out. I've been in deserts often. When you drop that pin in the sand, it becomes a problem to find it.
Yeah.
Sometimes you will not find it.
And if you do find it, because it's got oil on it, now it's covered in sand that you can't get off.
So you attempt to try and improve things for the user to make it easier for him. That when he strips it, he realizes, but this is actually quite nice.
Right. There's like 3 parts, and they're all big, and then I can do everything I need to on the gun.
Yeah.
That's, in fact, this goes back to the difference in evolution in your designing from the Neostead to the PAW.
Yeah.
The prototype of the Neostead, one thing you told me is you have to be careful with this thing not to short stroke it.
Yeah.
Because what happens if you short stroke it is you end up with 2 shells on the follower. And there is no way to remove them except to take the stock off. And on that prototype, in order to take the stock off, you had to go up into the pistol grip and take out a screw.
Yeah, absolutely.
And on the production version, they did actually simplify that. They put a button on the side so that you can just push the button, pull the stock off, and then you can fix this nightmare of 2 shells on the lifter at the same time.
Absolutely.
And then you get to the PAW and the NTW-20 as well, where it's like you push this, plop, that comes off, and then the bolt carrier comes out.
Absolutely.
It was cool to see on the NTW. There's 2 little detents to take off the whole back of basically the receiver cover, and the bolt stop is built into the receiver cover.
Yeah.
So normally on a bolt action rifle like that, what you do is you open the bolt and you have to pull the trigger to get it past the sear, and then hit some sort of bolt release spring-loaded mechanism. Well, on this one, there isn't a sear, it's a hammer fire.
Yeah.
it's cocked when you open the bolt, so you don't have to hold the trigger down.
Yeah.
And then because the bolt release is built into the receiver cover, which you have to take off to get the bolt out anyway, once the receiver cover's off, you just pull the bolt out the back.
The other important thing for me is for the user to be able to recognize what's in there.
Okay.
As you saw the PAW, when you pull it out, it's immediately recognizable. It's not a fangled dangle thing with all sorts of new flapper lockings and underlockings and collets and little springs and all this kind of stuff. It's a rugged, robust, chunky. How much more robust could you get?
Yeah, not a whole lot.
Yeah.
That's one of the, now it's a 20mm rifle.
Yeah.
But it's one of those things like a Mauser tank gewehr bolt where you can beat someone to death with the bolt easily.
Yeah. So my advice to anybody who's trying to design a gun, I hope you've got someone who's got lots and lots of money, a company that's willing to back you, a user who actually might believe in you. All these things help a little bit.
There's so much, like so many real enterprises.
Yeah.
There's so much more than just the core of what you think it is.
You know, I think luck has a lot to do with it.
Okay.
Wrong place, right time. I believe in the past, many good guns never went anywhere. Wrong place, wrong time. Guns that should never have survived a day ended up being produced.
SA-80.
Sure, you said it. I haven't said anything, but I think luck has a lot to do with it.
Okay. Can't control that.
Yeah, can't control it.
But you can at least go into the process with the right perspective.
Yeah.
So I think this was helpful. I know you were concerned going in. You're like, if we talk about this, it's just going to scare anybody off from ever wanting to do it.
No, that's not my intention at all. I just don't want anybody to suffer unnecessarily. I think it's like any business, really. I think you really got to know your oats, learn your oats, find out from other people, study, have a good sense of reference. You've seen my book collection. I attach a huge value to it.
Yep.
Any opportunity I get to see any new gun, I'll examine it. I'll extract out of it what I can, just like you do, which is why I appreciate your program.
My pleasure.
And I'm being serious. You know that I've learned a hell of a lot more in many different ways than out of my books. So unless you're that dedicated that you're willing to understand why all sorts of other guns work for all sorts of reasons, you're not going to start from scratch.
That makes sense. Well, it's fantastically heartwarming to hear that the work I've been doing actually helps people doing real firearms design.
Absolutely.
So I really hope someone picks up the PAW.
Yeah.
I think that thing has really cool potential.
Thank you. I appreciate it. I'm glad you shot it. You have an understanding of it, which is very difficult to explain to somebody in words or in pictures. But
well, thank you very much for taking the time.
Thank you very much. Thank you.
Hopefully you guys all enjoyed this. If you happen to work for a big gun company that would like to license production of the PAW, well, send me an email and I'll forward it on, because that'd be really cool to have happen. So, anyway, anything else you like to get off the chest?
Yeah, that's it. Yeah.
All right. Thanks for watching, guys.